Hello students, let's do set concepts exercise 6D. In this exercise, we are going to be doing operations on sets. There are different operations, so let's revise what these operations are. Now the first operation is a union of sets. What is the union of sets? Now suppose you have two sets, set A and set B. Then the union of these two sets will be one single set, a set which contains all the elements of the two sets A and B. And that is called the union of the two sets. For example, now suppose we have set A with A, B and C and set B with C, D and E. Then the union of set A and set B will be written like this, A union B. So we read it as A union B with this symbol. So this will be one set which contains all the elements of set A, that is A, B, C. First write all the elements of set A. Now look at set B. We're going to write all the elements of set B also here without repeating any element. Now C, D and E are the elements of set B, but C is already there, so we will not write that. We will write the other two elements, which is D and the other one is E. So this is called the union of the two sets A and B. A union B is all the elements of set A and set B without repeating any element. Next is intersection of sets. Again, if you take two sets, A and B, the set which contains only the elements common to both the sets. Okay, so in this case, we are not going to write all the elements like A union B. We are only going to write the elements which are common to the two sets. That is called intersection. And this is set A. Again, we are taking the same example A, B and C. And set B is C, D and E. Now, if we write A intersection B, this is how we write. This is the symbol for intersection and we read it as A intersection B. Now what are we going to do? We're looking at all the elements in A and all the elements in B and only going to pick out the ones that's common. Now what is common? As you can see, only C is common. So C is the element here. So A intersection B is only C. So the first operation is union of sets. Second operation is intersection of sets. Then we have the third one called the difference of sets. Again, the difference between two sets A and B is taken as A minus B or B minus A. Now, what do we mean when we say this? Where A minus B will be all the elements of set A which are not in set B. Did you understand? When you have A first, you write down all the elements of set A which are not there in set B. Now when you say B minus A, we'll write all the elements of set B which are not in set A. Let's do this with the help of an example. Now example, we have set A and set B. Now if I have to say A minus B. So now we're going to look at all the elements of set A. And if they are not in set B, we can write it down. So we have A. Now let's begin with the curly brackets. Now here. So A is not there in set B, so we can write that. Then, so that's A. Then B is also not there in set B, so we can write that. Now C is there, we cannot write. D is there, we cannot write. And E also we cannot write. So A minus B will be only A and B. So what have we written? We've written all the elements of set A which are not there in set B. Next is B minus A. This time we write all the elements of B which are not there in set A. So let's look at the elements in set B. C is there in set A, so we won't write C. So C we are not writing. Then what about D? D is also there in set A. E is also there in set A. We only have F and G. So let's write that F and G. So B minus A is all the elements in B which are not there in A. So this is the difference of sets. Now let's begin the exercise. Exercise D is on page number 91 and we are doing question 1. Now here the elements of set A are given, elements of set B are given. We have been asked to find A union B, A intersection B, A minus B and B minus A. So let's begin. A union B. Remember, A union B is where we write all the elements of A and all the elements of B without repeating. So let's write that. So that will be 4 So first thing is write all the elements in set A. So that is 4, 5, 6, 7 and 8. Now let's go to set B and write the elements of set B. But if they are already there in set A, you don't have to write. Now 6 is already there, 8 is already there. Now we have 10 and 12. So these are all the elements of A union B. Next, A intersection B, we're going to write only the elements which are common to both sets A and B. Now look at set A and let's see what's common. Now 4 is not there in B. Okay, we're looking at this. 4 is not there in B. 5 is not there. We have 6. Okay, so 6 is there both in A and B. 7 is not there. 8 is there in both A and B. So the intersection of A and B will be only 6 and 8. Next is A minus B. That means we're going to write all the elements of A which are not in B. So let's begin. So let's put the curly brackets. Now let's look at A. Now 4 is not there in set B, so we can write 4. 5 is also not there in set B, we can write 5. 6 is there in set B, so we cannot write. 7 is not there in set B, we can write that. 8 is there in set B, so we cannot write. So A minus B is 4, 5 and 7. Now the next one is B minus A. We're going to write all the elements of B which are not in set A. So let's begin. So here we start with 6. 6 is already there in set A. We will not write. 8 is also there in set A. We will not write. Now we have 10 and 12. So 10 and 12 are not there in set A. So B minus A is 10 and 12. Then, cardinal properties of sets. Now, before going on to the next question, we should know this. What is cardinal properties? Is very simple. If a set has 7 elements in it, or 5 elements, or 4, depending on how many elements, we say the cardinal number of that set is that number. So, suppose set A has 7 elements. The cardinal number is written like this, n of A, which is 7. Okay, it's a simple one. Now, here we have set A, B, C, D, E. Now, what is the cardinal number of set A? So, we write n of A is equal to, we count the number of elements, 1, 2, 3, 4, 5. So, the cardinal number is 5. This is very simple, isn't it? So, let's go on to the question. So, question 2 is this. If A has all these elements and B has all these elements, we have to find a few answers here. So, let's begin with first one. We have to find the cardinal number of set A. Let's count the number of elements. 1, 2, 3, 4, 5. So the answer is 5. The cardinal number of set A is 5. Now the cardinal number of set B. 1, 2, 3. Cardinal number of set B is 3. So we finished the first question, the second question. Third one, first we have to find A union B and then the cardinal number of A union B. So let's find out A union B. So start curly brackets, A union B, write all the elements of A first. So 3, 5, 7, 9 and 11. Now we're going to write the elements of B which are not there. If it's repeated, you don't have to write, otherwise you write everything. So now we have 4. Now 7 is already there, so we don't write, and then we have 10. So this is A union B. Now we have to find the cardinal number of A union B. That means how many elements are there. So let's count and see. 1, 2, 3, 4, 5, 6, 7. There are 7 elements. So the cardinal number of A union B is 7. The next question is, first we have to find A intersection B and then the cardinal number of A intersection B. Now A intersection B means only the elements that are common to both. So let's see, 3 is not there, 5 is not there, we have 7. 7 is common to both, so let's tick that. We have 7 that is common, 9 is not common and 11 is not common. So we have only one element when you write A intersection B. Now we have to find the second part, that is cardinal number of A intersection B. And that will be 1 because there's only one element in A intersection B. Question 3. If A is equal to 2, 4, 6, 8 and B is equal to 3, 6, 9, 12, we have to find a few things. A intersection B and the cardinal number of A intersection B, then A minus B and the cardinal number of A minus B and the cardinal number of set B. So let's begin first by finding A intersection B. So A intersection B will be only the elements that are common to both. So let's see, 2 is not there, 4 it's not there, 6, yes, 6 is common. So let's write down 6. 6 is common. Now what else is common? 8? No. So we have only 6. So A intersection B is 6 and the cardinal number of A intersection B will be 1. There's only one element, so it will be 1. The next question is, first we have to find A minus B. Okay, so let's find that A minus B. And that will be all the elements of set A which are not in B. So we have 2. 2 is not there in B, so I can write 2. So let me tick that. I can write 2. It's not there. Now what about 4? 4 is also not there, so I can write 4. 6 is there. I cannot write 6. 8 is not there. I can write 8. So A minus B is 2, 4 and 8. Now to write the cardinal number of A minus B. How many elements are there? 1, 2, 3. So my cardinal number is 3. Next one is cardinal number of set B. So all we have to do is count the number of elements in set B. 1, 2, 3, 4. There are 4 elements. So the cardinal number of set B will simply be 4. You just have to write the answer as 4. Question 4. Here, if P is X is such that X is a factor of 12. That means P is a factor of 12. All the factors of 12 will be in set P. And Q, X is such that X is a factor of 16. So what are the elements in Q? All the factors of 16. So first we have to find out all the actual elements and then find out cardinal number of P, cardinal number of Q and this third question. Okay, so the first one is P. Let's write down all the elements of P first. Okay. Now, X is such that X is a factor of 12. What are factors of 12? All the elements that will multiply to give you 12, like 1 into 12 is 12. Then 2 into what is 12? 2 into 6. Then 3 into 4 is 12. That's it. No other number will give you 12 when you multiply. So these are the factors. What are the factors here? 1, 2, 3, 4, 6 and 12. So let's write it down. 1, 2, 3, 4, 6 and 12. These are the these are the elements of set P. Now, what is the cardinal number? This is the first question. What is the cardinal number of set P? Let's count. 1, 2, 3, 4, 5, 6. The cardinal number of set P is 6. So all you have to do is write 6. Next is, let's write down the elements of set Q. So here Q, X is a factor of 16. That means all the factors of 16 will be the elements of set Q. So just like we did for 12, let's write the factors of 16. So 1 into 16 is 16. Then 2 8s are 16. What else will give you 16? 4 4s are 16. So what are the factors of 16? 1, 2, 4. You don't have to repeat 4 again. 8 and 16. So that will be 1, 2, 4, 8 and 16. So these are the elements of set Q. Now answer the second question, which is cardinal number of Q. How many elements are there? 1, 2, 3, 4, 5. There are 5 elements, so the cardinal number is 5. Next one. Now we have to find the difference of Q, these two sets, that is Q minus P. Q minus P and then the cardinal number of that. So let's do that. So we're going to first find out the elements of Q minus P. That means write all the elements of Q which are not there in P. So let's start 1. 1 is there. 2, 4, 8 is not there. So we can write 8 and 16. 16 is also not there. So we're going to write all the elements of this. Okay, so we've got the elements of Q minus P. Now, whenever The first letter is given, follow that. Okay, so Q minus P, that's why we looked at the set Q. All the elements of Q which are not in P are what we have written, and we've got two elements. Now, the cardinal number of Q minus P is 1, 2. If there are two elements in Q minus P, so the cardinal number of Q minus P is simply 2. So the answer here is 2. So we found the answer to all three questions. Question 5, M. Now these are the elements of set M, and what are they? X is such that X is, the element is a natural number between 0 and 8. Okay, so those are the elements of set M. Now what are the elements of set N? It's a natural number from 5 to 10. Okay, so first we have to write out all these elements and then answer these questions. So here, first let's write down all the elements of set M. So what is M? It's a natural number between 0 and 8. So natural numbers begin from 1. So we'll write 1, 2, 3, 4, 5, 6 and 7. Between means we don't write the last number. Okay, so we've got these numbers. So these are the elements of set M. Now, what are the elements of set N? N is a natural number here. X is a natural number from 5 to 10. So we start from 5. It says from 5 up to 10. 5, 6, 7, 8, 9 and 10. So now we have the elements of M and N. Now we can find these answers. First is M minus N. That means we write all the elements of set M which are not there in N. So let's see 1, 2, 3, 4. These numbers are not there. So let's write 1, 2, 3 and 4. Now what about the rest? Now 5, 6 and 7 are there in N. So we cannot write. So M minus N is 1, 2, 3 and 4. So these are the elements. So let's close the brackets here. So we found M minus N. Then we have to find the cardinal number of M minus N. Cardinal number means count the number of elements. 1, 2, 3, 4. There are 4 elements. So the cardinal number is 4. Now we have to find N minus M. That means all the elements in set N which are not there in set M. So let's see 5, 6 and 7 are there. Now 8, 9 and 10 are not there. So 8, 9 and 10 are the elements. 8, 9 and 10. These are the elements of N minus M. Now we have to find the cardinal number of this. 1, 2, 3. So the cardinal number is 3. Question 6. If A is equal to, these are the elements of A, what is it? X is a natural number divisible by 2 and X is less than 16. So you should be careful. We're talking about natural numbers and they are divisible by 2 and the numbers are less than 16. Whereas set B, X is such that X is a whole number divisible by 3 and X is less than 18. So first we have to find out the elements of set A and set B and then we can find out these answers. So let's begin. Now set A, its elements are natural numbers divisible by 2. So all even numbers are divisible by 2 and because it's a natural number we have to begin from 1 and see what are all the even numbers divisible by 2 and they should be less than 16. So let's begin by starting with 2 itself. 2, 4, 6, 8, 10, 12 and 14 because it's less than 16. So these are the elements of set A. Now set B, what are the elements? X is such that X is a whole number. Whole number means starting from 0. It should be divisible by 3 and it should be less than 18. That means tables of 3 less than 18 including 0 because we are talking about whole numbers. So 0, tables of 3. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15. We have to stop with this because it says less than 18. So we've got the elements of B. Now let's start answering the questions. First question is the cardinal number of set A. How many elements are there in set A? 1, 2, 3, 4, 5, 6, 7. So there are 7 elements in set A. So the cardinal number is 7. Next one, cardinal number of B. Let's count 1, 2, 3, 4, 5, 6. There are 6 elements, so the cardinal number is 6. Next one, A intersection B. Okay, so we have to first find A intersection B. That means what are the elements that are common to set A and set B. Now let's start with set A. 2, it's not there in set B. 4, no. 6, yes, 6 is there in both the sets. Then we go on to the next one. 8 is not there. 10 is not there. 12, yes, 12 is there. So these are the two elements that are common. So A intersection B will be 6 and 12. And we have to find this. We have to find the cardinal number of A intersection B. So let's do that. So cardinal number is, how many elements are there? 1, 2. So let's write the answer as 2. Next is, we have to find the cardinal number of A minus B. So first we have to find A minus B, isn't it? A minus B means all the elements in A which are not there in B. So let's look at set A and see what are the elements which are there in set A that are not there in set B. 2 is not there in set B, 4 is not there, 6 is there, 8 is not there, 10 is not there, 12 is there, and 14 is not there. So these are the elements of A minus B. What I've ticked: 2, 4, 8, 10 and 14. This is A minus B. Now we have to find the cardinal number of A minus B. This is the actual question. 1, 2, 3, 4, 5. The cardinal number is 5. So we will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.